Hey everyone, in this video we're gonna attempt the first question in section 16.3, least squares, trend fitting and forecasting. So this is a linear trend forecasting, and it is absolutely the same thing as linear regression. So they give you a data, x's and y's, you run the regression, and supposedly you end up with an equation. All right, so for the first question they did not run the data, they just gave you the equation. So the y hat is going to be 4.5 plus 1.8 times xi, right? So we can identify this is a b0, we can identify this is a slope b1. So definition of b0, definition of b1, that's what they wanted to identify on the first question. So A is talking about B0, which is the y-intercept. So the y-intercept is going to be 4.5. So it's going to be either the A or the C. And the 4.5, as a matter of fact, reflects, if I have trend like this, that's going to be when the origin of the data starts. And starting from 1962, as you can see here, the first number, right? So that's going to be the number of sales, or the amount of sales in billions, 4.5 billions in 1962. And that should be B0 is going to be C, the predicted net sales for 1962. All right, check it. Looks good. Now they are asking about B1. What is going to be B1? So B1 is a slope, and that's how much you're going to increase every year. All right, so because we have the data per year, and that's basically either B 1.8 or A. So it is B, which is the slope B1 1.8, indicate that the sales are predicted to increase 1.8 billion per year, and that's the slope. All right, and we got it. All right, so in this question here we want to figure out what is the value of the predicted sales, all right, in the 9th year. All right, so again, this is our regression line, so all the values are y hat, they are the predictive values. However, if you have the table the way that they did it, this is the years. So 1962 is here, and this is going to be the amount, the sales. Now, whenever you run your regression line, you don't run it with 1962 as the x's. So this is the xi's, this is the yi's. You run it as year number 0 here, and then 1963 will be year number 1. So those are the xi's that you're going to use, not this one, right? All right, so because we are using 0 and then 1, therefore the 9th year, for 9th year here, it will correspond to x8, not x9, because the 0 is counted. So you see 0, 1, so that's the second year corresponding to 1. All right, so what you're going to do, you just plug it in into the equation. So the equation should be, the value is equal to 4.5 plus 1.8 you multiplied by 8, which is x8. All right, and just you can use a regular calculator to do this. So let's plug it in. 4.5 plus 1.8 we multiplied by 8. All right, and that's going to be 18.9. Plug it in, check, and it's good. Now again, we're going to do the same thing. What is the fitted trend value for the most recent year? Or the most recent year is 2005. All right, and that's his 44 values, the number 44th. Again, we're going to subtract 1 from 44. So this is going to be the y equals to 4.5 plus 1.8 times, instead of 44 we're going to do 43, for the same reason that we made this logic, right? Okay, so we go back to calculator, plug it in. So here I'm going to change only 8 to 43, sorry. I changed 8 to 43, and that's going to be 81.9. Okay, it's good. Now For this one, they wanted to project the trend forecast for 4 years after the last value. So what we got? We have 44, that's the total number of years. That's the number here, you have the values. And then you're gonna add another 4, that's gonna be 48. However, remember, this is years, all right? You wanna turn it into x's, the corresponding x's to this. So the corresponding x for this one, you're gonna be 48 minus 1, and that's gonna be 47. And what we're gonna do exactly the same thing, plug it in. Y you're gonna be 4.5 plus 1.8 times 47. All right, and let's use the calculator. Let's change 43 to 47, and that's gonna be 89.1. Check. It's good, and we are all set.